यथास्थिति निर्धार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट। इसका उद्देश्य है सोलर पवन, सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य, सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्देश्य कक्षा की ओर बढ़ रहा है। आदित्य L1 के नितंभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजिबल एमिशन लाइन क्रोनोग्राफ VLC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और हेलियोस दोनों ही URO सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX और PAPA स्पेस फिजिक्स लेबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya L1 will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India has made history with the Chandrayaan-3 moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hats. In fact, these celestial bodies are very important and are considered as sacred bodies in multiple global religions. The sun is the central body of our solar system. The world revolves around it, and it is a source of energy for all planets, including the Earth. Today, I am joined by all the scientists who have played behind the scenes to make this project a grand success. And I am Srinidhi, reaching out to you from the Satish Dhawan Space Center, Sriharikota. And today we'll be discussing about the impact and the benefits of the Aditya L1 space mission. So today we are joined by Dr. Anil Bharadwaj, Director of PRL, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya L1 mission, Dr. Durgesh Tripathi, PI of SCYT, Dr. Dipankar Banerjee, Director of IRIS, Nainital, Dr. Satish Tampi, PI of PAPA, and Dr. Vipin K. Yadav, PI of Magnetometer, joining us today for a 25-minute fireside chat on the sidelines of Aditya L1 launch. To start with the Principal Scientist and PI of SOLEX, Dr. Sankara Subramaniam, why is Aditya L1 mission so important and what are the objectives of this mission?
Thanks a lot. First of all, let me thank ISRO as well as the Government of India for providing a great opportunity for the solar and heliophysics community of the country. Both solar, heliophysics as well as astronomy thrives on data. More the data you have, we get more understanding about the system. And sun is our own star, our dearmost star. So understanding them is much more important for our everyday life. So this mission, Aditya, when it was conceived initially, with a support from our Professor U.R. Rao, along with Dr. Srikumar and Professor G. Srinivasan, we made sure that we will have a unique data set which is not available from any other missions internationally. So the 7 payloads, what was conceived for this particular mission, will provide a unique set of data which is currently not available from any other missions, which will provide us new insight into the solar and heliophysics community in India, and provides some important aspects like the initiation of the coronal mass ejections, the speed at which it gets initiated, and some wavebands which are very important for the Earth ionospheric connections, like near ultraviolet band, and the high energy particles, which is high energy radiations, as well as particles which is coming from the solar flares and coronal mass ejections. So these are the informations which would be available from this particular mission, which will allow us to understand the sun, its dynamics, as well as the inner heliosphere, which is an important element for the current day technology, as well as the space weather aspects of it.
Thank you so much for your remarks, sir. So now we move on to Dr. Anil Bharadwaj. So the sun is a very important energy source of life. Having understood that, it creates a trouble when it's angry. How does Aditya L1 helps us through the mission?
Thank you and good morning, viewers. First of all, let me tell you that Aditya L1 is a multi-wavelength, multi-instrument and multi-directional mission. Multi-wavelength because it works in X-rays, UV and visible. Multi-instrument because there are 7 experiments on board. And multi-directional because it looks not only in the sun direction but also around it. Now when the sun becomes angry, there are 2 types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma, and that can take about 2 to 4 days to reach the earth. What we are looking for from the Aditya L1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the earth. We have instruments which look at not only in the sun direction, but also in other directions, for example, perpendicular to ecliptic or in the earth directions. The impact is that we need to see when the sun becomes quite angry, what are the ways in which it is affecting the planet Earth, and L1 point being at point L1, which is just 1% away from the Earth, it is able to provide us a lot of new informations of the plasma and the electromagnetic radiations which is reaching the planet Earth.
Thank you so much, sir. So now we'll move on to Dr. Annapurni Subramaniam. So the science behind this mission is very unique. So what's the impact of this on the Earth and also on the heliosphere?
Yeah, so thank you for having me on this show. To put the thing in context, I'm the director of Indian Institute of Astrophysics, and we have delivered one of the major payloads on this mission. This is the visible emission line coronagraph. So if you actually look at the words used in it, it is visible because it is seeing the sun in the visible wavelength. Emission line, so what is it detecting? It is the emission line of certain elements. Because the corona is hot, the emission which you get is in the terms of, it's not absorbing the light which is coming from the sun, but it's already hot, so it is coming down by emitting lines. So we are tracking these lines using what? A coronagraph. Now what is a coronagraph? This instrument makes a total solar eclipse all the time within the instrument. So you are looking at the sun all the time, 24/7 through using this mission. And this instrument looks at the sun as though it is always in total solar eclipse. Now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because when sun burps, when sun is angry, the corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona as close as possible from the disk of the sun.